Hello, seventh graders. So today, Mrs. Oliver, myself here, is going to bring you today's lesson on constant rate of change. Constant rate of change has to do with graphs and tables, kind of like what we've been working with, but there's a little bit difference more to it. All right, so today I will represent and identify constant rates of change. Okay, we know what proportional and non-proportional relationships look like out of tables and graphs. So we needed to know that before we could actually do our constant rate of change. And then this will help us determine if we have a non-proportional equation or a proportional equation. Okay, so this is going to go into our notebook, page 50. So do it right after the word problems that we did Tuesday. So let's think about something and kind of put this together. Okay, so every square is considered a rectangle because a rectangle has 4 right angle corners. But not every rectangle is a square because a square then means you have to have equal sides. So a square can be both, but a rectangle can only be a rectangle. So similarity, when we talk about graphs, a lot of times we'll talk about whether it is linear or nonlinear. And now we know what a proportional relationship is, and every proportional relationship is considered linear. If it is proportional, it is linear. But not every linear relationship can be proportional. Okay? So like when we looked at our graphs before, we had our linear ones that started at 0 and was a straight line. Right? Linear just means it's a straight line, but proportional is straight and starts at the origin. So that's why it can be linear, but if it doesn't start at the origin here, it's not proportional. So see how linear can be linear and proportional. Proportional is always linear, and linear is not always proportional. So if it is linear, it has what we call a constant rate of change. And we'll talk more about what the actual definition of that is when we get to our notes. So have them ready to go. All right, so this is chapter 1 and lesson 7 in our textbook. We have constant rate of change. Sometimes it might be the acronym CROC, C-R-O-C, so we know what that stands for. So a rate of change is a rate that describes how one quantity changes in relation to another. Okay, so a relationship has a constant rate of change if it makes a straight line. And constant means it's the same change that is happening every time. This time it may or may not start at the origin. Okay? Because if it is a straight line, it has a constant rate of change. So let's talk about how we can find the constant rate of change from a table. That's our focus today, is with tables. When we look at these, remember we have X is always on this side and Y is always on the right side. And we always want to look at what we would consider the Y first. How does it change when we go from one number to the other? Did we increase? And how much did we increase? So each time you notice these are going up by 15. Okay. But what about the change in the number of students? It doesn't change the same amount. Each time our students is increasing by 5. And that is important to know. Because if they are consistently the same number that they are changing, then it is constant. So remember when we would find our unit rates, we always want to take our y and divide it by x. So we're taking the number of textbooks and we're going to divide it by the number that the students is changing. This is also another way that we could find our unit rates. So we have 3 textbooks per student. So the constant rate of change is 3 textbooks per student. If you need to, pause this and fill it in. And go to our next table. Okay. So here we want to compare the change of money. So of course money is our y. Okay, so that's my y right there. How do we go from 8 to 4? Well, or 4 to 8. Take your most recent and go and subtract. And we get 4. So we know we increased by 4. Is 8 plus 4 12? Yes. 12 plus 16? Yes. So we would say the change of the money is by 4. But then we need to look at our hours, our x value. Okay, how do we go? 1 goes up 1 to 2, another 1 to 3, 1 more to 4. So our change in the hours is 1. So we want to write this as our fraction. Okay, so we have the change of money, 4 over 1, and as a unit rate, 4 over 1, then that gives us the unit rate of 4. Now, how can I write this as a sentence? Using pretty much the same form as before, the constant rates of change is, oops, not random, just having the same thing, is $4 per hour. All right. Let's go to the next one. Now this time, look, they took more stuff from us. So let's look, what does the table have? Okay, we know we need to find the change in our plant height. Okay, so we're going to increase this up. Well, what's 11 minus 4? 7. So we increased by 7. How did this increase? By 7. We went up again by 7. All right, next one. What is our change in days? Oops, I forgot to write 4 over here. Or 7. Okay, so change in days. Well, how did we change? We went up by 7, up by 7, up by 7. So the change in days equals 7. So basically then, we take our change of the plant type, divide it by the change in days. So we get 7 over 7 equals 1. So then let's write our sentence. Our sentence is the constant rate of change in 1 inch per day. So that's how far, or you can put your little 2 marks for 1 inch. Okay, so if you need to, pause that, make sure you have all the information. All right, so what about graphs though? Sometimes we gotta look at graphs and we gotta see, oh, how is this changing? Okay, so when we look at this, we want to look at where we know things are intersecting so that we can make our table as well. Okay, so we got easily 4 points we can see. Now remember, this is your X, this is your Y, or look at what it's telling you. For one girl, we have 4 bracelets. Okay, for 2 girls, we have 8. For 3, we go to 12. And then for 4, go to 16. Just to give you a visual where I'm finding these numbers from. Then we can use the table to also help fill in our information that we're trying to find. So how does the bracelets change from one unit to another? Well, when I look at this one, it goes up by 4, up by 4. So it's constantly changing up by 4. Okay. Then the next one, what's the change in girls? How do we go from 1 to 2? By adding 1, and so forth. So we would say 1 is a change. So the change in bracelets is 4 divided by 1. What's our unit rate? 4. Okay, so how do we write this as a sentence? Well, our sentence is the constant rate of change is 4 bracelets per girl. Alrighty. Looking good, looking good. Alright, so now we have a class 1. Boys versus girls. Students in Mr. Money's class. So here we have, if you notice in our graph, yes, we have 0, 0. Okay, but notice how my 1 does not intersect. So we're not going to use that as one of our ordered pairs. I actually want to use this order pair. Okay, then we look for another order pair. Then looking for another order pair. And we don't have a table this time. So we need to figure out, how are we changing? How does my X go from here to there? So we went from, and each one of these is by 1. So we have 1, 2, 3. So we went up 3 on our X's. You notice it's the same thing. 1, 2, 3, plus 3. So our change in girls is 3. What about for my boys? Using the same ordered pairs. How do I change going from this point up? Because that's where my other order pair is. Well, I went from 6 to 12. So that went up 6. And then this time, I went up 6. All right. So then we have 6 boys is our change there. I actually kind of want to change so it looks a little bit different. There we go. We're going to go went from this point plus 3. Plus 3. All right. So now let's make this into a fraction. So our change in boys is 6 over 3 girls. Well, what is 6 divided by 3? 2. So what's my unit rate? 2. Write this as a sentence. The constant rate of change is 2 boys per girl. Now, how do they know to put boys before girls? Remember this division. That means your per. Whatever is on top goes first, and whatever's on the bottom is after per. Okay, just in case you weren't sure where I was getting my information. All right. Now we have nothing to fill in. We have to do it all off of our own. Now remember, we are always comparing y over x. So I want to look at my y-axis, and then I'll look at my x-axis. Okay, so y is t-shirts. So change in t-shirts. Okay, so if I go up 1, it really is 5, because what's 30 minus 25? So each line went up by 5. So we're saying my change in t-shirts is 5. Then I'm going to look at my x-axis over here, and it is time. So we're going to look at our change in time, and that's by hours. So how far do we change when we go from these 2 points? We go from 8 to 9. So that's only a 1 hour change. Okay, and each time it does that. So if you notice, 2 lines make 1 hour. Then of course we got to put it together. Our change in delta sign is another thing that kind of tells you, hey, that means the word change. You can say change in t-shirts over our change in time, which is 5 over 1. So what is my unit rate? Our unit rate equals 5. So put it in our sentence form. Our sentence form. The constant rate of change is our unit rate is where we fill in 5 and then put what is on top first, t-shirts per hour. All right. Doing great. You guys, thank you for hanging in and watching this whole video through. So next you have your exit ticket. So you just need to go through and find the constant rate of change for both of your table and a graph.